So now we're going to start section 5.2, which is called Trigonometric Functions. Now, trigonometry is the study of triangles. And what we're going to do to get started is we're just going to be talking about functions that are defined on a right triangle. So let me show you what I'm talking about. We have a right triangle here, and we could pick any angle. We could either pick this one or we could pick one over here. Doesn't matter which one we have. And in a right triangle, we have the hypotenuse, which is always opposite the right angle. We have an opposite side that is across from the angle in focus, and we have an adjacent side. Now, adjacent just means next to. So this is the side that's next to the angle, and the opposite is the side across from. Now let's say we were to change things around. What if I put the angle over here? Well, then our adjacent side would be over here, and our opposite side would be across from that angle. So hopefully this explains how we label the different sides. And with the trigonometric functions, there are 6 trig functions we're going to be focusing on. You might have heard of the acronym SOHCAHTOA to define the 3 main trig functions, but I write SOHCAHTOA like this. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Let me write this out for you. Sine is a function, just like absolute value is a function, but where absolute value is defined as the distance from 0 on a number line, sine is defined as just the ratio of the opposite side of a right triangle over its hypotenuse. We pronounce sine, sine. Please don't say sin. Cosine, please don't say cos, is defined as the ratio of the adjacent side over the hypotenuse. And tangent is a trig function that defines the opposite side of your right triangle over the adjacent side. Now those 3, most of you probably already heard of, but we're actually going to talk about their reciprocals as well. When we're talking about their reciprocals, we write C, S, C. The first C stands for cosecant, and it's abbreviated CSC. And these are just the 3 main reciprocals, meaning if sine is opposite over hypotenuse, cosecant is going to be the hypotenuse over the opposite side. Secant is defined as the hypotenuse over the adjacent, and cotangent is defined as the adjacent side over the opposite. So those are just definitions. So let's take a look at how we're going to use these going forward. So what I would like you to do is find the values of the 6 trig functions if theta is in standard position and the point is on the terminal side. So let me show you what this is going to look like. We'll start with the point 3, 4. One, two, three. 1, 2, 3, 4. Now whenever we draw a trig function from now on, it's always going to connect to the origin, and it connects to the x-axis. The point that's sandwiched between the x-axis and the terminal side, that's where our angle is going to be. Always makes a right angle with the x-axis, and we should label the x value, the y value, and your hypotenuse. To find the hypotenuse, we do the Pythagorean theorem, with 3 squared plus 4 squared is equal to the hypotenuse squared. 9 plus 16 is 25. And your hypotenuse is always positive. So you don't have to worry about doing absolute value for the hypotenuse, but you could have a negative leg. So now that we have that defined, let's figure out our sine, cosine, and tangent values. And then we'll figure out C, S, C, where the first C is cosecant, then we have secant and cotangent. Sine would be the opposite side. If it helps you for now, you could label your sides. 4 is opposite the angle, and 3 is next to it. So sine would be the opposite side over the hypotenuse. We take the reciprocal, we get 5/4. Cosine is the adjacent side over the hypotenuse. Take the reciprocal, we get 5/3. Tangent is the opposite side over the adjacent. The reciprocal would be 3/4. That's how we do problems like this. Let's try another one. How about if b is -2, -5? Let's see what this looks like. The x value is -2. The y value is -5. Connected to the origin and to the x-axis. This is going to be our angle. We'll label our x value and we'll label our y value. And let's figure out our hypotenuse. -2 squared plus -5 squared is our hypotenuse squared. 4 plus 25 is 29. And you don't want to use decimals, so our hypotenuse is just going to be the square root of 29. And remember, our hypotenuse is always positive. So let's figure out our sine, cosine, and tangent. And then we'll figure out C, S, C. Now we have our hypotenuse. Look at the angle. The side next to it is called the adjacent side. Across from it is called the opposite side. So sine would be the opposite over the hypotenuse. So we could take the reciprocal of that, and that's our cosecant. It doesn't matter where the negative goes. Cosine would be the adjacent side over the hypotenuse. Take the reciprocal of that. And then tangent would be the opposite side over the adjacent. We could take the reciprocal of that. That's what we get. Now, most of these are pretty good, but remember, you can't have a radical in the denominator. So for sine and cosine here, I'm just going to rationalize them by multiplying by the square root of 29 over the square root of 29. That would get rid of the radical on the bottom, and everything would be fine. So we get -5 root 29 over 29, and cosine would be -2 root 29 over 29. We'll do one more. What if we had the point 0, 3? Now this one's a little bit different. The y value is 3, but we can't make a triangle with no x length. So we're going to have to get a little creative here. I'm going to draw a triangle here or over here. The y value of this triangle is 3. The x length is 0. So I know this doesn't make sense because, you can't have a 0 length. But this is what we need to do in order to do this problem. If you find the hypotenuse, it would be 0 squared plus 3 squared is equal to your hypotenuse squared. So 9 is your hypotenuse squared, or your hypotenuse is 3. Your angle is always between the x-axis and your terminal side. So it doesn't matter which triangle you use. You could use either one. I'm going to use the one on the right. This will be our opposite side, and we have our hypotenuse side. So let's figure out our sine, cosine, tangent, and then CSC. Sine would be the opposite over hypotenuse. Take the reciprocal, and that's cosecant. They're both 1. Cosine would be the adjacent side over the hypotenuse. So the reciprocal would be 3 over 0, which is undefined. If 0 is on top, that's just 0. And then tangent would be opposite over adjacent, which is undefined here, and the reciprocal of undefined would be 0. That's how we do those kind of examples. Next, I wanted to talk about what are called quadrantal angles. So quadrantal angles using the unit circle. We're going to have an in-depth conversation about the unit circle coming up. I really don't like the unit circle. What tends to happen is people memorize values and they're not quite sure where they come from. I'd rather you be able to figure them out on your own to answer problems instead of just memorizing numbers. So we'll have more of a discussion about that coming up. But when we're talking about quadrantal angles, which we talked about in the last section, we have to think about our unit circle. Now, we'll draw a circle here. Unit means the radius is 1. And we have a point along the circle. That point has an x-coordinate and a y-coordinate. It's a right angle, and this is our reference angle. Now, the sine, if our radius is 1, the sine of this angle would be the opposite side over 1, or just y. Cosine of this angle would be x over 1, or just x. And the tangent of this angle would be y over x. This is how we figure out quadrantal angles. Quadrantal angles, in our last section, we talked about being 0 degrees, 90 degrees, 180, and 270. And we could keep going if you want. But one thing I just wanted to talk about is the actual values of those points. So remember what we said. We said that the radius is 1. So a point at 0 degrees would have the coordinates 1, 0. That's what the value at this point would be at 0 degrees. At 90 degrees, if it's 1 unit from the origin, we're going to draw a point 0, 1. 180 would have the value negative 1, 0. 270 would one unit away from the origin would be 0, negative 1. So, if I asked you to find, let's say, the sine of 90 degrees, the sine is the y value at 90 degrees. The y value would be 1. If I asked you to find the cosine at 90 degrees, cosine is the x value of the point at 90 degrees, which is this, 0. If I asked you to find the cosecant of 90 degrees, it would be the reciprocal of what the sine was. So it's 1 over 1, or just 1. The secant of 90 degrees would be the reciprocal of cosine. So 1 over 0, which would be undefined. What if I asked you to find the tangent of 90 degrees? According to what we have here, tangent is the y value over the x value. So tangent of 90 would be undefined. And you could check this on your calculator, but this is how I want you to know how to do it by hand. The cotangent of 90 degrees would be the reciprocal of tangent, which is 0. That's how that works, and this works for all kind of quadrantal angles. And the quadrantal angles are the angles that fall, of course, along the quadrants. So let's do some examples here. Find the indicated values. So let's say I asked you, what's the sine of 360 degrees? Well, sine's the y value. 360 degrees is right here. The y value is 0. What about the cosecant of 270? Well, what we do is we figure out the sine value, and the answer is going to be 1 over the sine value at 270. Sine value at 270 is the y value, so the answer is -1. 1 over -1 is -1. What about the tangent of 180? Tangent, remember, is the y over x value. So the y value over the x value would be 0 over -1, which is 0. What about the cosine of -90 degrees? Well, -90 degrees is right here. Remember, -90 degrees, we would go clockwise. The cosine of -90 would be the x value right here, which is 0. What about the cotangent of 0 degrees? The cotangent of 0 degrees, well, that would be 1 over the tangent at 0. Tangent's y over x. So 1 divided by 0 over 1 is 1 times 1 over 0, or undefined. How about the tangent of 0 minus 6 times the sine of 90 degrees? Well, the tangent of 0 is y over x. So at 0 degrees, the y value is 0, the x value is 1, minus 6 times the y value at 90 degrees. So 0 minus 6 is -6. How about 4 times the cosecant of 270 plus 3 times the cosine of 180? Well, the cosecant of 470 would be 1 over the sine of 270, and cosine of 180 is the x value at 180. The sine of 270, sine is the y value, which is -1. So we have 4 times 1 over -1 plus -3. -4 minus 3 is -7. We'll try one more. How about 2 sine squared of 90 degrees minus 5 cosine squared of 180? Now what this notation means is this means 2 times the sine of 90 squared minus 5 times the cosine of 180 degrees squared. So the sine of 90 is the y value at 90, which is 1. 2 times 1 squared is just 2, minus 5 times the cosine of 180. Cosine, remember, is the x value. Negative 1 squared is 1, so 2 minus 5 is negative 3. That's how we handle quadrantal angles. Now in the next section, we're going to be talking about finding special triangles. So generally we have two types of trigonometric angles. We have quadrantal angles, which hopefully you understand now, and we have special triangles, which come from 30, 60, 90 and 45, 45, 90 triangles. So let's move on to finding some reciprocals. So given the following, use the reciprocal identities to answer. And when we're talking about reciprocal identities, that's what we talked about in the beginning of today's section. If you remember, sine was the reciprocal of cosecant. Or the way that I put it was cosecant is the reciprocal of sine. We talked about this and we've used it, but this is maybe just another way to look at it. If you know what secant is, you could find cosine as just 1 over the secant. Similarly, if you know what cosine is, secant is just 1 over cosine. Tangent would be 1 over the cotangent value of theta, and cotangent is 1 over the tangent of theta. So let's take a look at a couple examples like this. What if I told you that sine was 1/2? I would like you to find cosecant of theta. Well, it's pretty easy. I mean, what's the reciprocal of 1/2? It's 2, right? Cosecant would be 1 over 1/2, which is 1 divided by 1/2, which is 1 times 2 over 1. I mean, I think it's just easier just to flip sign, right? But either way, you get 2 as the answer. Similarly, if we had the tangent of theta was equal to √3 over 2, what would the cotangent be? Well, we could just take the reciprocal. Tangent and cotangents are reciprocal, so we're going to do 2 over √3, and then we'll rationalize by multiplying by √3 over itself, which gives us 2 √3 over the square root of 9. This would be our answer. Okay, continuing on with our discussion, let's talk about the signs of trig functions. Trigonometric functions. So when we have trig functions, we've talked a little bit about how we draw these. They're always connected to the origin and the x-axis. So you can see we made a little bow tie here. Our right angles are like this. Whenever we're drawing special triangles, this is always how our triangles look. They never go off the other axis. I'm not even going to mention the other axis. They always connect to the x-axis. So if you're looking at these signs, the hypotenuses, if that's a word, they're all positive. Along the positive x-coordinate, that's positive. The positive y values have positive sides. Anytime you go down, that would be a negative side. And we have the negative x-axis. So let's go quadrant by quadrant. And we're only going to name the trig functions where they're positive. So in the first quadrant, quadrant 1, all trig functions are positive because you have a positive opposite side, positive adjacent side, and a positive hypotenuse. All three sides are positive. In quadrant 2, if we have our angle where it is, we have a positive opposite side and a positive hypotenuse. So what trig function uses an opposite side and a hypotenuse? Sine. So sine and cosecant would be positive in quadrant 2. How about in quadrant 3? Quadrant 3 is right here. What trig function would be positive here? Well, we have two negative sides and a positive hypotenuse. So sine and cosine would both be negative. You would have a negative over a positive. But what about tangent? Tangent would have a negative opposite and a negative adjacent, meaning that tangent would be positive, and so would cotangent. And then in our last quadrant, we have a positive adjacent side and a positive hypotenuse, so that means that in quadrant 4, cosine would be positive and secant. Now there's an old trick to remember this. The expression goes that, here I'll write it out like this. Well, maybe I'll use a different color. All students take calculus. The first letter tells you what trig functions are positive where. So which trig functions are positive in each quadrant? All of them are positive in the first. Just sine and cosecant are in the second. Just tangent is in the third, and cotangent. And C stands for cosine and secant. We're going to be using this as the course progresses, so it's important that you understand that. So what I would like you to do is to state the signs of the 6 trig functions of, let's say, 108 degrees. Well, 108 degrees would be past 90, but it's in this second quadrant here. So we have sine, cosine, tangent, C, S, C. We're just looking to figure out what's positive and what's negative for 108 degrees. Well, because it's in the second quadrant and all students, so sine is positive there, that means cosecant is, and everything else is negative. The cotangent of 108, the tangent of 108, cosine of 108, the only ones that are positive would be sine and cosecant. And we'll do one more for this example. What about 300 degrees? 300 degrees puts us right here in quadrant 4, past 270, but not quite at 360. It's in quadrant 4, so if all students take calculus, that means that just cosine's positive, secant's positive, everything else would be negative. All right, and let's move on to our last topic for this section. It's called the Pythagorean Identities. Now, the Pythagorean identities come from the Pythagorean theorem. So if we have our unit circle, I'll show you where they come from. We have a point that has an x and a y value. The hypotenuse is 1. Here's our angle. And remember, the sine of theta would be equal to the opposite over 1. Cosine of theta is equal to the adjacent over 1. So what would y squared plus x squared equal 1 squared turn into? Well, I'm just writing the Pythagorean theorem, right? Because we have a right triangle. We said y was sine. We said that x was cosine. So there we go. That's a Pythagorean identity. That's the main one. From here, what we could do is we could actually divide each term by sine squared and come up with new identities. So sine squared divided by sine squared is 1. Cosine squared divided by sine squared, we're going to be learning about soon, but cosine squared divided by sine squared just turns into cotangent squared. And 1 divided by sine squared, that's a reciprocal identity for cosecant squared. That gives us another identity. We'll be learning about the cotangent when we talk about quotient properties. I don't just want to just tell you these and ask you to memorize them. I want you to understand where they come from. And our third property is if we divide each of these terms by cosine squared. Sine squared divided by cosine squared, we're going to be learning that is just tangent squared of theta. Cosine squared divided by itself is 1. 1 divided by cosine squared of theta is secant squared of theta. So we have these 3 identities. This is the main one I want you to remember. You need to know this off the top of your head. Some people memorize these other 2, but it's not necessary as long as you know sine squared plus cosine squared is 1. If you want to memorize these, it might make your life a little bit easier, but it's not totally necessary. So let's see if we could do some more examples based on the Pythagorean identities. Find sine of theta given cosine of theta is 4/5 and theta is in quadrant 2. Okay, so we know for sure we're in quadrant 2. And in quadrant 2, remember sine is positive. So eventually we're going to need to use that for the problem, but let's do things step by step. We have to find sine, and we're given cosine. So let's figure out which formula we're going to use. Sine and cosine would use this formula right here. So we know that sine squared plus cosine squared is 1. So let's substitute in. Cosine is 4/5. So this would mean that sine squared of theta plus 4/5 squared is equal to 1. Sine squared of theta plus 16 over 25 is 1. Sine squared of theta is equal to, well, we have to bring this on the other side, so we'll subtract 16 over 25 from 1. That's 25 over 25 minus 16 over 25 is 9 over 25. And when you go to take the square root of this, remember, whenever you take the square root of something squared, it is absolute value, and we get 3/5. So this would give us sine is positive or negative 3/5. But we know that theta is in quadrant 2. So when theta is in quadrant 2, sine is just positive. So our only answer, sine has to just be positive 3/5, and that's where that comes from. Our last example, let's give the values of the 6 trigonometric functions for, let's do cosine theta is negative 2/5, and we are in quadrant 2. Okay, so there's a couple different ways we could do it. We could draw it, or we can use an identity for it. Drawing might be a little bit faster. So we're definitely in quadrant 2, and cosine is negative 2/5. Remember, our angle is always connected to the x-axis. Now, which one's negative, the hypotenuse or the adjacent side? Remember, the hypotenuse is always positive, so that means the 2 has to be negative. And we have to use Pythagorean theorem to find our other leg. So we get 4 plus y squared is equal to 25. Y squared would be 21, and y would be, the absolute value of y would be plus or minus the square root of 21. Which one would it be? Your triangle is going up, right? So that is a positive side. Just positive the square root of 21. So now we should be able to give an answer for all 6 trig values. We just had to set it up. Okay. Well, we know cosine's negative 2/5, so I mean that's pretty easy. Let's do that, and secant would be the reciprocal. Doesn't matter where you put the negative. Generally, calculators like the negative on top, but it's still technically correct if you have it on the bottom or in the middle. Sine would be the opposite side over the hypotenuse. So I'm going to write the square root of 21 over 5, where the reciprocal would be 5 over the square root of 21 for cosecant, and then let's rationalize it. And then for tangent, we're going to write the opposite over the adjacent. And we'll rationalize the cotangent, root 21 over itself. So we get negative 2 root 21 over 21. And our tangent answer would be this. Okay, we'll do one more and then that'll be it for this section. What about if tangent of theta was root 3 and theta is in quadrant 3? Okay, so we'd be over there. Now we don't have a fraction, but we can make any number into a fraction by writing it over 1. Tangent, if you remember, is opposite over adjacent. In quadrant 3, I'm sorry. Didn't look right. Quadrant 3 would be over here. So here's our angle, the opposite over adjacent. But anytime you go left or down, that side has to be negative. So we just need a hypotenuse. So let's take our legs, square them. And that's going to equal our hypotenuse squared. 1 plus 3 is 4. So our hypotenuse would be plus or minus 2, but the hypotenuse is always positive. So we have an opposite side and we have an adjacent side. So let's figure out our 6 trig functions. Sine would be the opposite over hypotenuse. Taking the reciprocal, we just have to rationalize. You don't have to multiply by the negative, just the radical's the problem. So it actually doesn't even matter where you put the negative. The answer would be negative 2 root 3 over 3. Cosine would be the adjacent over hypotenuse. So we don't have to worry about rationalizing anything. And then tangent, well, we were told what tangent is, root 3. We wrote root 3 over 1, but root 3 would just be a simpler answer. And the cotangent would be the reciprocal, 1 over root 3, which we should then rationalize, and we get root 3 over 3. Okay, thank you for your attention. Stay tuned for the next section.